Professor Dasgupta, I'm coming to you now. At this present moment, when we are just really minutes away from the landing of Curiosity on the surface of Mars, can you help us understand what goes on inside the minds of scientists while they are waiting at this critical juncture, when they'll not even have information for the first 14 minutes on whether Curiosity has even landed on the surface of or not?
Obviously, I mean, the scientists will be not even breathing. They'll be so tense because this is a project in which more than $2.5 billion have been spent, and the mission requires a precision, because the trajectory of the Curiosity rover not only is determined by gravity, but is also determined by the tenuous atmosphere that Mars has. So if there is any wind, then the parachute, which will be finally causing Mars to land on the surface, that can drift. So a mission of this kind, the controls, because once the rover is close to the surface of Mars, the controls which are in the hands of the scientists are also not operational any longer, and therefore the scientists involved in the project would be praying to God that nothing will go wrong and everything will fall into place with predetermined plans.
Well, absolutely, and we can see the scientists, they're busy in the last few minutes before Curiosity lands on the surface of Mars for that big mission. Let me go back to Mr. Raza in Ahmedabad. Sir, as this mission starts, and for the first 14 minutes there will be no communication, can you help us understand why it takes that amount of time for first information to trickle in?
See, as you go beyond a certain distance from Earth, the communication becomes increasingly difficult. Every child knows these days that light from sun coming to Earth takes about 8 minutes, 7.8 minutes approximately. Now, once we are sending a signal which is not at the speed of light, which is lower than the speed of light, these are high intensity radio signals through which we communicate. Now, if we are going, suppose it's a mission on moon, then we can control things in time. If there is a threat, if there is some malfunctioning in the whole gadget that we send there, if there is that malfunctioning, we can take corrective measures immediately, which will send the signal, receive the signal first, then send the signal for corrective measures. Now here is a situation where we have gone beyond a certain limit, where receiving a signal, if something goes wrong, or if we don't want something to happen, or we want to give instructions, receiving a signal from there and sending it back to that probe is time consuming in itself. Now, by the time you send the signal back, there is going to be a problem. So it becomes increasingly difficult. You have to have a mind of its own when you are sending something like this.
All right.
And so that it can take corrective measures. So you think of all the possibilities, and the computers there should take corrective measures based on eventualities that a probe faces. Now,
all right,
you have asked the question, why these 17 minutes? The speed with which it will be descending needs all the correction that is to be done at that particular moment, operated by the computers within the thing.
All right.
Unless and until it descends down and lowers and settles on the surface, it cannot start sending messages from there.